Hello, everyone. I just wasted 17 seconds talking to you and you didn't even hear me. This is a review of the day before 6.2 day number 1. Let's talk about a couple of items. First of all, the degree of this polynomial would be x to the third times x to the fourth times x to the second. Don't forget the negative 5 out in front. This will give us our leading term, which should be negative 5x to the ninth. That gives me an end behavior that looks like that. Okay, I have zeros of negative 2, 0, and 1. So here's negative 2. Oh, look at how nice I was. Here's 0. And here's 1. Now, I know end behavior-wise, from the left of that far point and from the right of this far 0, that's what it's going to look like. Where will it bounce? It'll bounce at 1. Why? Because the multiplicity there is even. It'll also bounce at 0 because the multiplicity there is even. So this graph is going to bounce here because it's even multiplicity. It's going to bounce here because it's even multiplicity. And it's going to pass through because of the odd multiplicity. There is some freedom in how I've sketched this, right? How low is this low? How low can you go? Can you go down low? I don't know. You can go as low as you want to with your sketch, but this point is required, this point is required, this point is required, and your end behavior is required. Right? Because guess what's so nice about this one? That's also the y-intercept. Oh! Wow, that was aggressive. We are going to do a little bit of polynomial division today. We did it a little bit yesterday, but if I divided 5 into the number, I don't know, 117, does 5 go into 1? No, but does it go into 11? Yes, twice, right? So now I can take my trusty brain, and wait, that's kind of an overstatement, but I'm going to multiply 2 by 5 and get 10. What do I do with that 10? Yeah, you go and you minus that. And I bring down that 7. And I see how many times 5 goes into 17, which is trace. Multiply trace times 5, you get them 15. And then I get this 2 left over. Right? So that's 23 and 2/5. So far, so good? Yes? I don't like decimals. Do you want to put this into a decimal over here? No. Joey. Joey, you just made YouTube. You might get a penny in the mail in about 8 months. Yeah. All right. So let's talk about them there problems right here. On the left side, you'll see polynomial long division. On the right side, you see synthetic division. We'll equate what they mean and why they mean what they do. Okay, so how many times does x go into x cubed? No. No. The answer is up there. How many times does x squared times? Yeah, we multiply x times x squared, and we get x cubed. Okay, so I don't really like the way this is set up right now. Hold on. Scratch this first. Goes in x squared times, right? So now I take x squared, and I multiply that by x. I get x cubed. And I multiply it by negative 2, and I get, what the heck, negative 2x squared. Okay, I see what happened. They subtracted the negative 2x squared. Okay. All right, they subtracted the negative 2x squared and made it positive. I don't really like the way that's set up, but whatever. We'll deal with it. So here, let me do it for you. Let me make this very, very nice and clear. Okay, we multiplied by x and got x cubed. And we multiply by negative 2, we get negative 2x squared. All right, if I were to subtract the negative 2, wouldn't I just be adding 2? Yeah. Okay, so let's do this. Oh, yes, the x cubes disappear. What does this become? How many x squareds? 6x squared. And I'm going to drop down the negative 5x. Let's see what happens. Now, how many times does x go into 6x squared? 6x times. Let's see if that's right. Yeah, hello. 6x times. Okay, so then we go back to the drawing board here. And I want white. Where's the white? There's the white. There we go. Thank you. Now I'm going to multiply 6x times both of those. So I get 6x squared minus 12x. I'm going to subtract that. Negative 5 minus a negative 12 will be a positive 7x. And I'm going to drop down this negative 14. Oh, I love that. Why? Because x times 7 is 7x. And therefore, this better be a 7. Let's see if it is. Let's go and then erase it. It is. Oh, hello. So let's finish this off. I know this is now going to be a multiple, which means that this will be a factor. 7 times x minus 2 is 7x minus 14. And when I subtract, I get a remainder of 0. All right, let's see. I'm going to pull this purple sheet away, and we'll see if I did it right. Oh, yes, I did. Yes, you can see that. Yes, you can. Is that nice? So this, what is this garbage up here? What is this? P of x equals this times this plus that. It's garbage. But P of x is just what we started with. X cubed plus 4x squared minus 5x minus 14. What would d of x and q of x be? Chow and chow. What if I multiply those two together? What would I get? P of x. Right? So I got x minus 2 times x squared plus 6x plus 7. And then do I have a remainder? I don't. I have 0 of these. But what would I put under that? Like over here, look at this. I took my remainder and I divided it by this thing. So what would I put there? X minus 2. Cool. All right, now some of you are going to be amazed and you're going to love polynomial long division. You're going to love it. You ready? Watch this. I'm going to highlight some things. It's going to be fun. Ready? X cubed, what's its coefficient? 1. 4x squared, what's its coefficient? 4. Negative 5x, negative 5. Negative 14, negative 14. Where in the world did this, where did this 2 come from? It's the opposite of this factor, right? It's the solution to that factor. So if this were x plus 7, what would this number over here be? Negative 7. Good. And here's how polynomial synthetic division works. Does anybody remember? Okay. So the first thing you do, is you drop down the 1. You drop down the first number, okay? And then we take 2, this 2, and we multiply it by 1. What do you get? 2. Nice. Ooh. Now what do you think I should do with the 4 and the 2? What do we do in long division? We subtract it. We add in synthetic long division. We do the opposite. Why? Because isn't 2 the opposite of x minus 2? Right? So I think of it as the opposite. So I'm going to multiply 2 and 1, I get 2. And I add 4 and 2, I get 6. What do you think I should do next? Multiply what? 2 and 6. If I multiply 2 by 6, I get 12. I add negative 5 and 12, I get 7. Then I multiply 2 and 7. What do you get? 14. You add them together, you get 0. So one more time. Let's see what we get here. Let's highlight this. 1. Where does that 1 show up? Oh, 1x squared. Where does the 6 show up? Oh, 6x. Oh. And then, of course, the 7 is our constant. Oh, that's nice. You can. You can do polynomial long division using synthetic division. You can actually also do synthetic division with imaginary numbers. You can. Okay, so I made up this example. I'm not sure if this will come out nicely. I'm not sure, but I can still write out this function in p of x equals d of x times g of x plus the remainder of x, right? So I'm not going to do that. What should I use in synthetic division? Yeah, let's go 6. All right, and then now this is where I want you to be careful. This is wrong. Oops, sorry. I'm in long division mode. We should go like this, and then we should go like that. Okay. This is wrong. Why is that wrong? Yeah, Joey. Yeah, there's no x cubed there. So where should I put the 0? In between the 1 and the -7. So let's toss a 0 in there. And let's figure out whether or not this is a factor. Whether or not x minus 6 is a factor. Zach. So I corrected a child because they told me only 1 0, and I knew there was supposed to be 2. Welcome to mathematics. Okay, so now let's do polynomial synthetic division. Okay, so what do I do with the 1? Bring it down. What do I do with the 6 and the 1? Multiply. What do I do with the 0 and the 6? Add. What do I do with the 6 and the 6? Multiply. Then I add. Then I multiply. Gross. Then I add. Then I multiply. No. I think that's right. And then I add. Oh, so great. That's awesome. I have a remainder. Way to go, Mr. Ludd. Okay, so let's write out this set of polynomials. Oh, gosh. Ick. All right, so x to the 4th minus 7x squared plus 11. X to the 4th minus 7x squared plus 11 equals x minus 6 times, let's figure out what this is. So this right here would be my constant, 174. This right here would be my x term, 29x. This right here would be my x squared term. And this right here would be my cubic term. Okay, and then I'm going to add on my remainder. Ew! I missed a 0? Where? 1055. Way to go, Mr. Lon. Yeah, that's long division. That's creepy. Okay, so using the remainder theorem, if p of 2 equals 0, then we know that x minus 2 is a factor. So let's confirm it. Let's plug in 0. What's 3 times 0? 0. What's -6 times 0? 0. What's 4 times 0? 0. Minus 8. Is that equal to 0? No. So x minus 2 is not a factor. What the heck? Why did I do zeros? Well done. What should I have plugged in here and here and here? 2. What a fail. Hold on. Do I have enough time? Yes, I do. Let's do it. P of 2. What's 3 times 2 cubed? Oh, nice. Nice. I want that. Okay, what's -6 times 2 squared? There we go. Okay. What's 4 times 2? That's 8. And minus 8. Yes, that equals 0. Therefore, x minus 2 is a factor. So I could do long division, or I could take 2 and synthetically divide it with 3 -6, 4 -8. And now we can go. We know we should get a 0 here, right? So here we go. Hey, what the heck? All right, so here we go. Synthetically divide. What do I do, Maureen, with the 3? Bring it down. Hello? Multiply. I get 6. I add. I get 0. I multiply 2 times 0. I get 0. I drop the 4 down. I get 4. I multiply 2 times 4. I get 8. And then, oh, there we go. I got 0. So I could write this polynomial as x minus 2 times, tell me what this would mean. 304. 3x squared plus 4. Yeah. Chow. And that, folks, is how I would factor, oops, that function right there.